So we're going to talk about your rate law lab, which we'll be doing next time. And this is a lab in which you are going to be determining the rate law for the reaction that you see down here. Obviously, you want to take a little bit of time to read the introduction and even the procedure and even everything on the back here, on the back of the sheet there, the write-up and the questions. Okay. But after you've done that, let's talk a little bit about what you're doing. So here's the reaction that we're doing. It looks a little bit strange because it's an ionic equation, so we've got some ions involved instead of everything being uncharged and just balanced charges. But that's okay. It really doesn't, not really the point here. We're going to just focus on these ions. And you're going to come up with a rate law. Essentially what we're looking for is, where A is this HSO3, which is called bisulfite. It's just a polyatomic ion that you've never had before, or you've never memorized, but it's called bisulfite. And then IO3 1- is iodate. And we're looking essentially for M and N, which is essentially another way of just saying to what power would we raise each of these in writing the rate law. How does each of these separately affect the rate of the reaction? Okay. So this is a unique reaction. We're able to time the reaction because it actually involves a color change. And I'll show you a little bit. This is just a video somebody made. Took this from YouTube, so this is. Here, I'll bring it over here and give them credit there. You can see the name there. But it's essentially just a reaction that is very colorful. So it changes colors once you mix the two solutions together. So you can see there that's what they're doing. This is being done on a stir plate. You see a little stir bar spinning, and we'll have one of those going as well. And if you just keep watching, it goes from clear and very suddenly is going to change to, yeah, this like dark purple, almost black color, like ink. And so by timing how long it takes from the mixture, from the point of mixture to the point where you get that color change, we're able to come up with a reaction rate very easily for this reaction. And so that's what you guys are going to be doing. So to get ready for the lab, a couple of things have to be done here. First of all, you have to understand, if you read this last little bit here, it says to calculate the average rate over the course of the reaction, you have to remember the blue-black color occurs when the sodium bisulfite is used up. And so we're talking about, it says sodium bisulfite, but it's really referring to just the bisulfite. That's all we're worried about, the HSO3 1-. So when that gets used up, the reaction is over and you get the color change. That's how you know the reaction is done. Okay? And so if it's used up, that means its final concentration is 0. So the initial concentration would also be the change in concentration. So if it starts at 0.1 molar, it's going to end at 0. So therefore the change in concentration would be 0.1 molar, right? So we're able to easily get the change in concentration for the reaction, the rate for the reaction by just looking at the change in concentration of the bisulfite, which is also equal to the starting concentration of the bisulfite. Okay? And then we can just, of course, divide by the number of seconds that it took for the reaction to happen to get the rate. Okay, so we're starting with two solutions. Solution 1 is the iodate, IO3 1-, and the bottles that I'll have available in the class have a molarity of 0.024 molar. So that's the starting concentration. And the other solution, the bisulfite, is 0.016 molar bisulfite. And so you can see here, you're going to be doing 7 trials, and the concentrations are not written here. You're going to have to come up with the concentrations yourself, and I'll talk about that in just a second. But you'll notice that the total volume for each trial is 100 milliliters. So we have 10 plus 80 milliliters of water plus 10 milliliters of solution 2. That's going to give you 20 plus 70 plus 10, and so forth. They all add up to 100 milliliters. And that's going to be important because what that means is when we mix together the two solutions and the water, the total volume, which will help you get the concentration of each solution, the total volume is going to be 100 milliliters. Okay? So, looking at this table is not going to be, it's not our concentrations, it's just volumes. So you're going to have to make your own table that gives the concentration of solution 1 and solution 2 in this, in each reaction or in each trial. So let's talk about that. And this is the procedure. You should read this to be ready to go. But the thing that I want you to have done when you come in is this first part. It says, make a table showing the concentration of each ion and the average rate of each reaction in terms of bisulfite for each of the 7 reactions. So that table is going to be set up when you come in. Obviously, you're not going to have all of the data, but you should be able to have all of the concentrations of the solutions. So let's talk about how to do that, okay? And again, it's all going to be based on these volumes, okay? So I've started to set up just an empty table. This is just 8 rows and 6 columns. So you can draw one of these on a clean sheet of paper and fill them in. So I give you a second, or you pause the video, go ahead and create one using a ruler, or if you or however you want to do it. You can do it freehand if you can be neat about it. So our titles, first of all, the far left column here, we're going to have trials, and then we're going to have concentration of iodate, concentration of bisulfite, then we're going to have time for the reaction in seconds. We're going to have average time, once again in seconds, and then we're going to have rate, which is going to be molarity over seconds. And remember, when we calculate rate, we're just looking at the change in molarity of the bisulfite divided by the average time. Now, you're going to be doing 2 trials for each of the different concentrations. So for each trial you see on this sheet, there are 7 trials here. For each of those trials, you're actually going to be doing it twice. So you're actually going to be doing 14 reactions total. Okay? So let's talk about how to set this up then. So for trials, under trials, you're actually going to have to fit 2 lines of data in there, and I'm going to call them 1A and 1B. And if it's a little bit crowded, because I didn't tell you that you had to have 2 trials in each row, but you really only need that row to be divided into 1A and 1B for time. So if you'll divide your time column in half, okay, all the way down, because you're doing 2 trials, but the concentration of iodate will be the same in trial 1A and 1B. And the concentration of bisulfite will be the same in trial 1A and 1B, because 1A and 1B both refer to trial 1 from your procedure. Okay, so they're going to have the same amounts of iodate and bisulfite and water, and so therefore the concentrations are going to be the same for 1A and 1B. But you will have 2 different times, so that's the only cell you need to split in half. Okay, and then average time, of course, is going to be one number because it's an average, and then you're going to get your rate based on the average time. Okay, and the concentration of bisulfite. Okay, so let's talk about how to figure out your concentrations, and then I'll do the first one with you, and you can do the rest on your own. So for iodate, I'm going to go back to my sheet for a second here. It says that iodate has an original concentration of 0.024 molar. It's potassium iodate, but really it's just the iodate is the thing we're concerned with. So we have to figure out what the concentration is of the iodate if I'm using 10 milliliters of that concentration, but I'm adding 90 milliliters of other stuff so that the new volume is 100 milliliters. Okay, so if we think about this, essentially it's an M1V1 equals M2V2. If you go all the way back to our discussion of diluting solutions or doing serial dilutions in the beginning of the year, we did this. Molarity 1 times volume 1 equals molarity 2 times volume 2. And so to figure out the molarity of the iodate for trial 1, I'm going to say that my original molarity was 0.024 molar, and that had a volume of 10 milliliters. And then I want to know what the new molarity is. Usually we're solving for molarity 1, but in this case we're solving for molarity 2. It really doesn't matter. And our new volume, after we mix it all together, is 100 milliliters. So just to make sure you understand why those are my numbers, we go back to the procedure. You have 10 milliliters of the original concentration, which is 0.024 molar, and once we mix them together, like at the instant that everything comes together, the new molarity of the potassium iodate or the iodate would be based on having 100 milliliters, but still just the same number of moles I had in 10 milliliters of 0.024 molar. So there we go. So now it's just a matter of, dividing both sides by 100, which for this one you should be able to do in your head, because if we multiply by 10 and divide by 100, that's just like dividing by 10, right? So M2 for the potassium iodate should be 0.0024 molar. So I'm just moving the decimal over one spot. So I'm going to go back up to my table, and for trial 1, A and B, remember it's the same, I put in the concentration 0.0024 molar. All right? And then I can do the same thing for the bisulfite. Okay? Remember, the original concentration of the bisulfite is 0.016 molar. Okay, so that's a little bit different, but we're still using 10 milliliters out of the total 100. So, you could kind of probably predict this yourself or figure it out yourself. Essentially, it's going to be the same thing. It's going to be 0.0016 molar, but just to show my work here, this time it's going to be 0.016 molar, 10 milliliters of it. So what is M2 if we now go to 100 milliliters total when I mix everything together? Divide both sides by 100, which is the same as, once we multiply by 10, is the same as dividing by 10. So there we go. And we do, in fact, of course, get 0.0016. Okay. Now, when you do this in class, you're going to be, mixing things together exactly as it says in the procedure. You're going to start with one of them in the beaker on a stirrer plate, which will give you the little stirring effect that you saw in the video. And you're going to be adding the other, starting a stopwatch, and recording your time. And then you're going to do it again, clean everything out, start all over. So you got to measure again, and get a second time. And then you're going to average them. And then again, your rate is very important. If you, let's just say hypothetically, just throwing numbers out there, I have no idea if this is going to be your average time, but let's just say hypothetically it takes, 17.5 seconds on average. Okay? When you go to get your rate, the procedure is telling you that it's the bisulfite that's totally disappearing, meaning the color changes when the bisulfite gets used up. So your rate every time will simply be the original molarity of the bisulfite divided by the number of seconds, the average number of seconds. Okay, and that's what you're going to have right here. Okay, and then once you have that, you can look at your concentration of iodate, concentration of bisulfite for each trial, and then the rate, and you should be able to write a rate law. It's not going to be quite as perfect as what we had in our examples when we did stuff in class in terms of getting really close to a whole number, but you should at least be able to get pretty consistent data that results in a good rate law. So make sure that you bring this table filled out, at least in terms of your concentrations, on a clean sheet of paper. This is going to be turned in. Obviously, you're just going to have the first 3 columns filled out. 1A, 1B, concentration, 2A, 2B, same thing. And then we'll collect the time data in class, do your averages, and do your rates, and answer the questions. So just make sure that you're 100% ready to go, having read the procedure, complete this table, and we should be able to get through all 14 of those reactions in the 90 minutes we have on Friday.